Directed line segment AB has endpoints with coordinates A, -2, 5, -1, -2, 1, 2, 3, 4, 5. B, 8, -1, 1, 2, 3, 4, 5, 6, 7, 8, -1. And so typically when we're doing these type of problems, the easiest way to solve this problem would be using a graph paper. However, it has its limitations, as you're going to see with this problem. If you are dealing with whole number answers, then this is very easy. However, this question in particular, you're going to deal with decimals. So, like I said, it has its limitations. But let's continue this method. So first what we did was we graphed the line segment AB, and what's going on in this question is that we need to find the coordinates of P, so meaning point P is somewhere on this line segment AB in a way that it divides the line segment in a ratio of 3 to 2. So what we're going to do is we're going to draw a right triangle out of this line segment. And you can draw it any way. You can draw it the way I just did, or you could have drawn it above here as well. I made this one a bit too long, so let's try that again. Okay, so I drew a right triangle out of this line segment AB, and so I can either count the segment vertically or horizontally. So I'll just try horizontally first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here I have 10 parts. Now when you go back to the ratio, you have to understand, first you have to understand how many total parts this line segment is going to be separated. And so we have 3 plus 2, which means 5 total parts. Now when we did the graphing method here, I counted horizontally 10 spaces. So what we're going to do is 10 divided by 5, which is 2. So what that means is every 2 boxes, I'm going to go 1, 2, shoop, and then I meet at the line segment. 1, 2, shoop, and then meet at the line segment. 1, 2, shoop, meet at the line segment. 1, 2, shoop, meet at the line segment. Now continuing this pattern, as you can see, we have separated the original line segment AB into 1, 2, 3, 4, 5 equal parts, which was the goal. Now we said that point P is somewhere on this line segment AB, and remember we started with A, so you start with point A, and the ratio goes from 3 to 2. So that's 1, 2, 3, and so therefore P has to be here because that's 1, 2, 3, and then this is the 1, 2, 3 to 2. Now, if you look over here, point P is not a whole number, right? It's right in between. So this is what I mean about this graphing method has its limitations. I know that it's going to be 1, 2, 3, 4. So I know the coordinates is going to start with 4, comma, but I'm not quite sure exactly what, but here it's like 1 and 2. So it's like between 1 and 2. Okay, so now let's go ahead and try the actual formula method. So the formula method is as follows. You start with the point that you're starting with. So here we're starting with A since the segment is AB. And what you're going to do is solve for each of the letters separately. So right now we're going to look for the X value for P. So that's why I start with -2. And then eventually we're going to start with the Y value. And so that's why we start with 5. Keep in mind when we're doing the ratio, we're going past A. So when you're going past A, you're adding. So right now I'm looking at the X. So what I'm going to do is go past this number. And how much past am I going to go? I'm going to go 3/5 the distance between the X's. What does that mean? Well, to go from A to this point P they're mentioning, we got 3, so that's the 3. And 3 plus 2 is 5, so that's 3/5 the distance between the X's. Now, which x's are we dealing with? Well, right now we're dealing with the x's here, so I'm going to plug in 8 minus a negative 2. Whenever you're finding the distance of something, you usually do the later minus what came before. So 8 minus negative 2. So now if I were to put this all in the calculator, I have negative 2 plus 3/5 of 10. I'm just going to do the calculation, but like I said, you can just put this in the calculator. So 5 times 1 is 5, 5 times 2 is 10, 3 times 2 is 6, and so negative 2 plus 6 equals 4. Now keep in mind, before we already solved the x value for p, it was 4. Now we're going to solve for y. So we're going to continue the same idea. So now we're looking at y. So I start with 5. I'm going past that number. What I'm going to do is go 3/5 the distance between the y's. So we're going to look at the later y, which is negative 1, minus the before y, which was the 5. And like I said, you could put this all in the calculator, but I'm just going to show the calculation. Negative 1 minus 5, that's going to be negative 6. And so here we have 5, and then positive 3 times a negative 6 is going to be a negative 18, and then divided by 5. So we're going to put this in the calculator, but I'm just going to do the calculation. So we need a common denominator of 5. So what I multiply in the bottom, I multiply to the top. So 25 minus 18 gives me 7. So therefore, my y coordinate here is now 7/5, which really is, like what we said before, it is between 1 and 2. But we would never have gotten this exact value using the graphing method. So therefore, the point P is 4, 7/5.